I broke it into 8 equal parts. How much is each little section going to be?
1/4 pi.
1/4 pi, or pi force. And what is pi force in degrees? Oh my gosh, that's one of my special angles from the triangles I was supposed to know. I'm going to stick with radians because I'm confident that you could count by 45 degrees if you needed to, right? Like if this is 45 degrees, well, you should even just know how many degrees is this? 90 degrees. Or in radians, think about force. If this is 1/4 pi, and I add another 1/4 pi, how much pi do I have?
2/4 pi.
2/4, which reduces to pi halves, right? That's 90 degrees. And how many fourths, right? Think about the back of the day when you had the pi and you color it in. If this is 1/4 pi, and this is 1/4 pi, and this is 1/4 pi, how many fourths do I have? 3/4, or 3 pi fourths.
Well, we should do those actually.
That should be our homework.
No, but hopefully this makes sense to you on how to count these. And we know this is pi, but does it make sense that this is 4 pi fourths, which I'm just going to reduce to pi, because that's 4 pieces of the 8 pieces, 4 out of 8. Nope, just kidding. Never mind.
Stop it.
How much would 1/4 more than 1 pi be? 5 pi fourths. Thank you so much for not saying 1 and 1/4.
I almost did, but I can't remember what it was. You could tell us.
5 pi fourths. And this would be 6 pi fourths, or reduces to 3 pi halves.
You just threw it.
Just threw it out here. 3 pi halves. And how many fourths would this be?
1 3/4 pi.
Stop it. 1, 2, 3, 4, 5, 6, 7 pi fourths. And it should make sense if we went all the way back around. We would be at 8 pi fourths. And is 8 pi fourths 2 pi? Yes. You need to know these multiples of force because they are multiples of 45 degrees, which are going to be very important to us later this week. Okay? What's the other special triangle that we know? 30, 60, 90. So we want to break this up into increments of 30 degrees or 12 equal parts. Ready? So in each one of these, we need to break it up into 3 parts, like here and here, roughly. That's not that good, but that's okay. Like here and here. That's terrible. Okay, I gotta go back.
You can't just erase it. I like the Bible.
Oh.
Very good.
These are terrible. That's right.
That's the worst one.
It's all about how you label it, not what it actually looks like.
No, but that's whoa, that's never good stuff. Remember that.
It's true. Unless it says label the angle. Here, look, I'm gonna cheat. That's terrible too.
My circle sucks. Why don't you use your
I'm just going back to my
lovely circles.
hand drawn one. I don't care.
Oh, it was really good.
Cottage cheese circle.
I'm going back. I don't care. How much is each one of these going to be if the whole thing is 2 pi and I broke it into 12 equal parts? 30 degrees, or in radians.
I don't know.
So this is 12 equal parts over, oh wait, I screwed that up. 2 pi into 12 parts would be pi 6. That's a terrible pi 6, but we're going to go with it. Everybody done with these 12 marks?
Yeah, I'll tell you right now, my service bad.
We're going to make that a little better. Oh, that looks better.
That looks a lot better.
Again, think about, we can count by 6 here. What is pi 6 and pi 6?
Pi thirds.
2 pi 6, which is pi thirds. This is still 0. This would be 3 pi 6, which is still reduces to pi halves. You see how you can count by 6 all the way around?
Why do we do 6?
12 equal parts divided, 2 pi divided by 12, because the whole thing around is 2 pi. Just like on the last one, we divided into 8 equal parts. So that's why it's pi fourths. This would be 4 pi 6, which reduces to 2 pi thirds. And think about thirds here. That would be like 1/3. That would be 2/3. This is 1/6 away from pi. So how many sixths is that? 5 pi 6. Right? I'm telling you, you're going to at least learn fractions from me. And this would be 6 pi 6, which is pi. This is 1/6 more than pi. 7 pi 6. This would be 8 pi 6, or 4 pi thirds. This is a bad little quadrant here. 9 pi 6 still reduces to 3 pi halves. 10 pi 6 is 5 pi thirds. And this should be, even though it looks way too big, 1/6 away from 2 pi, 11 pi 6. And I really, really, really need you to be using these improper fractions. Okay? So the reason that I make you learn a 30, 60, 90 triangle and a 40 by 45, 90 triangle is because when we extend these angles around the entire circle, we can talk about multiples of 30 degrees, 60 degrees, and 45 degrees. Okay? Not doing a whole lot with that today, maybe, but I'm going to just keep throwing this at you until you feel good with it. Okay. Up until now, we've only talked about acute angles with trig, right? Angles less than 90 degrees. But today we're going to extend it to all angles. And so instead of talking about SOHCAHTOA, we're going to talk about angles just anywhere on the circle. So write this, and we're going to draw a little angle here. Why? Because I didn't print your notes out? No, this is just this page. So I want you to draw an angle over in quadrant 2. I don't really care where, but after you get in this room. My computer is going to stop working.
It's got the red dot.
I know. Thank you.
Stop this.
So I'm going to show my little arrow that I'm going like this, and I'm going to put theta right here. And so here's what this says in here. It says, let theta be an angle in standard position with xy a point on the terminal ray of theta. So some point out here, I'm just going to pick that point, and I'm going to label it as xy. We could not make a right triangle out of theta. Do you agree with me on that? Because theta is bigger than 90 degrees. Theta is obtuse. But what's really cool is we can still find the trig values, only instead of talking about opposite, hypotenuse, and adjacent, we're going to relate them to the points x, y. And so think about, what if I dropped down the height here, or what if I just drew in a little side of the triangle there? I can make that noise, it helps you. We're talking about this more tomorrow, but that little triangle I just drew is called a reference triangle. And you can use that reference triangle to find all the trig values of this theta over here, even though this triangle is over here. How long would this side of the triangle be? Yes, I'm just going to go with x. But yes, because we're in quadrant 2, Olivier was right. This would really be negative x over here because that would really be a negative x, right? So we're just going to go with x. Just humor right now. He's getting ahead of us. Because it's x this way, and this way is the height, which happens to be the y coordinate, yes? And could I do Pythagorean theorem here to figure out what this is? Yes, that's where this comes in. Instead of calling it the hypotenuse, they're going to call this r. What do you think r stands for?
Radius.
The radius. Because I could draw the circle that goes through that point, and this would be the radius of that circle. So I'm just going to call this r. They tell us that r equals the square root of x squared plus y squared. Where the heck did that equation come from? That's just Pythagorean theorem. They just solved for r. So instead of saying r squared equals x squared plus y squared, they're just solving for r. You with me on that? So no new equation. It's just Pythagorean theorem. So to find sine, cosine, and tangent of any point on the coordinate plane, whether it's in quadrant 1, 2, 3, or 4, you can draw the whole triangle in, or you can just learn this ratio, that sine would now still be, if you thought of it as opposite over hypotenuse, would be the y coordinate of that point over r. Cosine, if we think about coming from here, cosine you could still think of as adjacent over hypotenuse, but in the coordinate plane here, it's always going to be x over r. And tangent is still going to be opposite over adjacent, only in terms of y's and x's. The opposite would be y, and the adjacent would be x. We do need to say where x is not allowed to equal 0, because sometimes x does equal 0, which means sometimes there is no tangent value. Notice I don't have to say that on sine and cosine, because the radius is not 0, and it even says up here the radius cannot equal 0. We can do the same thing for our lovely reciprocal functions. Flip them over, but because x and y could be 0, all of the reciprocal functions have a chance of being undefined. So cosecant would be r over y, and we're going to say where y is not allowed to equal 0. Secant is r over x, where x is not allowed to equal 0. And cotangent is x over y, where y is not allowed to equal 0. But Olivier already made a really good point about this. Because we're going outside the first quadrant, because our angles can be bigger than 90 degrees now, sometimes our trig functions are going to be negative. And so you really have to think about where you are, what quadrant you're in, where that point would be. You don't necessarily have to draw the picture every time, but let's do one together, kind of draw the picture, and then let's talk about how we can figure out where the signs would be positive and negative, and then maybe another one.
So what are they negative?
Let's look at one. Like this. Instead of giving you a triangle now, they can just give you a point. Let the point negative 12, 5 be a point on the terminal ray of theta. Find these trig functions. I just picked sine, cosine, tangent. We can find all 6 if you really want. We could just flip them over. I know, that's why I didn't do it. So you don't necessarily have to draw the picture, but I want to draw the picture on this one just to show you. I'm not actually going to label the point negative 12, 5. I'm just going to figure out what quadrant it is in. What quadrant would the point negative 12, 5 be in? So that'd be over negative 12 up 5. So here's what I mean by drawing the picture very vaguely, because it's all about labeling. I'm going to say this is negative 12, this is 5, right? So if I drew in an angle that is on the ray that has the point negative 12, 5, it would look something like that. So here's what's nice about these new ratios. You don't need a triangle anymore, right? We've always had to draw a triangle. We've had to think of SOHCAHTOA. If you these ratios, you don't even need the triangle, because what did we say the ratio for sine was? Y over r. Oh wait, do I have an r yet? No. I have an x and I have a y. Can I find an r without drawing a picture?
Yes.
Because what is r always going to equal? The square root of x squared plus y squared. Which in this case, and when you square a negative, it's always positive, so you should never get a negative answer under here. That's going to be 144 plus 25, which is the square root of 169, which is a radius or a hypotenuse of 13. If you like the picture, draw the picture, and you can label it. You can say, okay, if I drew this triangle in, this would be 13. This would be a negative 12 because it's over here on this side of the x-axis. This would be a height of positive 5. So if you like the triangle, you can use the triangle. But what's really nice about this is you no longer are required to have a triangle, because if you know x, if you know y, and you know r, and you know the ratios, for me, I just say, oh, sine is y over r. Here's my y, here's my r. I can say it's 5 over 13 without actually having to draw the triangle. Follow me on that? The ratio for cosine is x over r. And if you don't know that, that's where the triangle is helpful, because you can just look at this and say, if here's my angle, then adjacent over hypotenuse. And now cosine is going to be negative, because the x is negative 12, and the hypotenuse, or the radius, is 13. And the tangent would be what? Y over x, or in this case, 5 over negative 12. And remember with fractions, it doesn't matter if you put that negative on the top or the bottom. 5 over negative 12 is the same as negative 5 over 12, which is the same as the negative out front. It just matters that there's a negative sign on that. And then you can do the reciprocal function here also. So let's think about if we can figure out which quadrants, which trig functions would be positive and negative in, and see if we can see a way that we can do this without having to think too much. All right, so draw another one of these. We're going to write sine, cosine, and tangent in each one of these little boxes if you want to think about how big to write this. We're going to write sine, cosine, tangent.
In every box?
In every box. Sine, cosine, tangent.
Sines and trig functions.
Get it? Sine, sine. Oh my goodness. Sine.
Are we going to have to put anything else in this thing?
Maybe like an ordered pair like this. So you need 4 things. I'm going to print this out. You don't have to worry about it, huh? It's good for you to write your own notes, children.
We're gonna, like, when we are all grown up, like, teachers, like, I remember we had better, this was terrible. We're gonna have a laptop tomorrow, get with it or something, and an iPad.
Or just a robot teaching you.
Yeah, or that's really depressing, because I want to be teaching in the classroom.
It's not going to be a robot.
It's just gonna get erase all of this.
Just my voice. 100 years. Parker the other day said, do you know in 2115 we're gonna all be dead? And I thought he meant like February 1st. And I looked at my husband and I was like, why is he saying that? And but he meant like the year 2115. But it was still a little creepy.
We're all gonna be dead in like 2 weeks.
He said everybody but Nolan was gonna be dead for sure.
Oh, I thought he meant like all people.
No, they just are family. Like, but I thought he meant February 1st. So I was like, that's really soon. Are you planning to
That's weird. I don't remember.
But no, he meant a whole 100 years.
Are you sure? Did you ask him?
I did. I was agree.
You realize you should have told you to recover for himself.
He may be. Okay, so
Just watch yourself.
remember that sine is y over r, cosine is x over r, tangent is y over x, which means if you know the signs of y and x, you know if your trig functions are positive and negative. And I could have written all 6 trig functions, but do you agree if sine is positive, then cosecant is going to be positive? If tangent's positive, cotangent's going to be positive. So their reciprocal functions go with them. There's no need to write them all out. In quadrant 1, do you agree that the x-coordinate and the y-coordinate are always positive?
Yes.
Which is why, up until today, when we've only been dealing with less than 90-degree angles, all of our trig functions have been positive. Yes? So in the first quadrant, everything's positive. Everything's happy. Should I write theta here so you don't think it's... Let's write theta. They're all positive. Positive, positive, positive. What about every point in quadrant 2? What are the points going to look like? The x is always going to be negative, and the y is always going to be positive. So if you know that, and you know these ratios, you can tell me which trig functions are going to be negative in quadrant 2. Wrong. Because sine is y over r, right? And y is still positive, so sine is still positive. But cosine is x over r. And x is negative, so your cosine better be negative. And tangent, what about it? Because positive over negative is negative. What about quadrant 3? The points are all negative, right? X is negative and y is negative. Wait, you're wrong again, Grady.
No, I meant like that's.
Yeah. Tangent's going to be positive because a negative over a negative is a positive. But sine and cosine are going to be negative because r is never negative. So if x is negative, cosine's negative. If y is negative. You're okay, Grady. I'm with you. What about in quadrant 4? The x is positive, but we're down here with a negative y. And so cosine's going to be positive because x is positive. But you agree the other two are negative? If you notice from this, every trig function is positive in 2 quadrants and negative in 2 quadrants. Which means when we get to solving equations, we're going to see that, and graphing, we're going to see that the same answers come up more than one time because of this. You don't have to memorize this, right? This should just be, if you know this, you should be able to figure this out, right? Like, I'm never going to make you reproduce this chart. It's just supposed to help you. You have some questions on your homework today that just say, figure out if this would be positive or negative, because they want you to think about the ratios, not actually computing it. So I think this might be my last slide.
I was not expecting. Liar.
This is my last slide. Like, I meant, like, this is my last slide.
So is tomorrow's unit circle?
We're getting there. Actually, tomorrow's reference angles. Wednesday's the unit circle. Thursday's the unit circle worksheet. Like, that's why we're not having a test next week.
Be here on Wednesday. Should we come to school on Wednesday?
Yes, unit circle's a big day. Saw Dylan at Red Lobster this weekend.
I heard your voice. I was like, oh no.
Wait, who are you with?
I think you're like the next booth over from me, right?
Probably across
My children are very bad at restaurants, but he's like, oh no. I'm a very loud person, Dylan. Should know that by now.
Was the deal okay?
He left right before I even got my food, so he didn't have to listen to me that long.
So you didn't know how to do this?
He didn't know.
I never heard her husband. Her husband was like really close to me. Probably like this far away. I didn't hear the whole time.
I didn't let him talk. He was like behind me. Like, I didn't see him until he walked by. Like, it was very awkward. Like, no, he was like, hi, Miss Dixon. And I was like, oh, hi. He did. Miss Dixon.
I would have not said anything at all.
I don't walk by her. So.
I would be like,
Actually, I guess
That's what teachers do. That's what teachers do the same thing. When we see you out, we're just like, oh.
Okay, quick time. We were getting an order for our boat, and I remember his parents and dad as I was rowing down the aisle of Walmart seeing the boat. And her dad just looked at me as he looked and walked away, and he died. And his parents were
So, Determine the sign of this without using a calculator, which means could you cheat and use a calculator? Of course you could, but that's not going to help you in the whole long-term part here. You're supposed to think cosine is x over r. What quadrant is 299 degrees going to be in?
3 or 4.
Yeah, somewhere over here in quadrant 4. So in quadrant 4, is x positive or negative? Positive, which means cosine is positive. Your answer is positive. 2 pi thirds. What quadrant is 2 pi thirds in? Is 2 pi thirds bigger than 1 pi?
It's in second quadrant 2.
Right. If this is pi, 2/3 of pi is more than half of pi, which means this is in quadrant 2. What's the ratio for tangent?
Y over x. It's negative.
In quadrant 2, y is positive, but x is negative, so the answer is negative. Right? So the idea is you don't need a calculator, you don't need to actually compute it, you're just thinking about which quadrants are positive and negative, and maybe practicing knowing those angles. Yes? That's not so bad, right? How about this homework? Eight questions. And I'm pretty sure 17 through 20 are the positive, negative ones.
So I give him like A, B, and C, like.
Nope. I don't know, actually, but I did this, actually. I did this.
So tomorrow at the end of the day, you're gonna play the unit circle song.
Wednesday, maybe. I don't think we do unit circle till
At the end of the
Wednesday.
day, it's gotta be like, you gotta make them want to come back.
We did the unit circle,
I heard that on the radio Saturday.
What station?
93.5.